Okay. Today's essential question is, what are the characteristics of rational and irrational numbers? Okay, so we're obviously going to be learning the difference between a rational and an irrational number. We're also going to learn some other things about numbers, like what natural numbers are, whole numbers, integers, and then of course rational and irrational. Okay, when you were a small child, okay, what type of numbers did your parents try to teach you first? Right, 1, 2, 3, 4, 5, 6, and up, right? Those are considered the natural numbers, okay? So like 1, see over here the number sprinkles, 1 would be considered a natural number, 2 would be considered a natural number, 3, okay, and so I'm going to mark them out as I use them. And then 10 is a natural number. Okay, the counting numbers is what some people call them, are natural numbers. Now, when you get to whole numbers, that is natural numbers plus 0. Okay, so the reason the ice cream scoops are like they are is because these are just natural numbers. But whole numbers include the natural numbers and 0. So whole numbers is like 0, 1, 2, 3, 4, 5, and up. Integers is natural numbers and whole numbers, but in addition to that, negative whole numbers. So numbers like -1, -2, and -3, those would be considered integers. But now remember, integers also include whole numbers, so 0 is also an integer, and the positive whole numbers. So integers are like -1 to -100, or infinity, basically, whole numbers, and +1 to infinity, whole numbers, and then 0. Now, rational numbers are no longer just whole numbers. Rational numbers can be a fraction. So like 1.5, is that a fraction? Well, it may not be written in one right now, but look, if I do 1.5 on my calculator and then I do alpha y equals number 4, which will take a decimal and turn it into a fraction, it can be a fraction. So 1.5 is rational because you are able to make it a fraction. Now, the easiest way that I can help you remember that rational means that it needs to be a fraction is because what are the first 5 letters in the word rational? Ratio, right? Which is a fraction. Okay, so now 3/4, that's a fraction, so that would be a rational number. Okay, now let's talk about 0.009. Currently, it's not written in fraction form, but let's see if it will become a fraction. 0.009 alpha y equals number 4 is the one that will turn a decimal into a fraction, or vice versa if you're trying to go the other way. And it became a fraction. So that means 0.009 is rational because we were able to turn it into 9/1000. Okay, what about 5/6? Would it be considered rational? Yes, it's already a fraction, already a ratio. Okay, now let's talk about 1.76. 1.76 alpha y equals number 4 to try to change it to a fraction, and it became 1, 44/25. So 1.76 is a rational number. Okay, is 3/2 a rational number? Yes, it's definitely a fraction. Let's not worry about this x squared. Pi/4, okay? This one's tricky because it's in fraction form, but watch what happens if I type that in. I'm going to use alpha y equals n/d to set up for a fraction, and then in the top I'm going to type in pi. Okay, we'll look over here below clear. You see that blue pi symbol? So to get it on the screen, what do we have to press first? So second and then pi, and then over 4 equals that. Now, see how this number doesn't like have a repeating pattern and it doesn't terminate, it continues going on? And watch, if I try to turn it into a fraction using number 4, it will not become a fraction. It just keeps spitting out that decimal value. So pi/4 is not rational. That's what we would consider irrational. because it won't become a fraction. Okay, pi is always irrational. Okay, so put pi in the irrational, but don't let that confuse you with this. Even though, yes, most of y'all know pi is 3.14, let me show you the difference. If I just do pi on my calculator, that's what I get. Okay, well, when I try to turn it into a fraction, it just spits back out that 3.141592654. But if I just type in 3.14, which I know is what we normally say for pi, but if I just type in that and I do alpha y equals number 4, that will turn into a fraction because the decimal terminates after the 4. It doesn't continue forever. So pi is irrational, but 3.14 is rational. It will become a fraction because it terminates after the 4. Does that make sense? Okay, what is the square root of 100? 10. So that's a natural number, right? Now remember, natural numbers are also whole numbers. Whole numbers are also integers. Integers are rational numbers. Okay, so if it's a natural number, then it's also a whole number. If it's a whole number, it's also an integer. If it's an integer, it's also rational. Does that make sense? Okay, and then the last one, where would we put this? What would that be classified as? Rational. It's definitely not natural or whole or integer, but it is a fraction, so that is considered rational. So negative 2/17. Okay, now we're going to practice some of these in your packet, so you can close up your interactive notebook and turn in your packet to page 24. No, I forgot last period because I'm so rushed to get these last two things taught. So I will check it next Thursday. So you have plenty of time to get it done. Oh, is it? Sorry. Okay, I will check it next Thursday, and then I will immediately take up those pink sheets, okay? So make sure you have it done if you didn't already do it last night, and I'll take them up as soon as I stamp next week. All right, page 24. Page 24, last page. No, I just wanted to get started. We're not even going to get finished, but I just need to at least teach as much as I can because we have to test next Friday. So we got to review next Thursday. All right, number 1. It says simplify each of the following and label each solution as rational or irrational. Okay, so for this page, you're not going to have to worry about classifying them as natural, whole, or integer. You're just going to have to classify them as rational, which means will become a fraction, or irrational, which means will not become a fraction. But before you do that, you've got to simplify it, and you'll write the simplified answer on this line. So the first thing we're going to do is type it in, the square root of 25 plus 1.75. So the square root of 25, make sure you arrow over to get out from under the radical, plus 1.75. Okay, we get 6.75, which terminates, but just to make sure, let's do alpha y equals number 4 and see if it will become a fraction. And it did, right? 27/4. So that is definitely rational because it became a fraction. Okay, so now number 2, let's type it in. Square root of 3 plus 1.75. Okay, you get a decimal that does not have a repeating pattern and it does not terminate. But I'm always on the safe side. I always just hit alpha y equals number 4 anyway. It did not spit out a fraction, so that's the answer, 3.48205. Hold on, I already forgot it. 3.48. 205, and then 0808, I think, which is definitely considered irrational because it would not become a fraction. Okay, number 3. Now, you can just continue typing them in like I'm doing, and the calculator will give you the answer. Or some of you may find it faster to know that this is 4 plus 10, which is what? Isn't the square root of 16 4 and the square root of 110? And 4 plus 10 is 14, and isn't that what your calculator spit out if you typed it in? Now, can 14 become a fraction? Yes. Can't any whole number just be placed over 1 and still be the exact same thing? So all whole numbers are considered rational. Remember with the little ice cream cone, anything up here in the top scoops is rational. Okay? If it's natural, it's also whole, it's also integer, it's also rational. If it's whole, it's also integer or rational. If it's an integer, it's also rational. Those all go down into that. They all belong to the rational category. But just because it's this doesn't mean it's this. You can't go back up the scoops. Okay, so now let's look at number 4. The square root of 4 plus the square root of 5. Square root of 4 plus the square root of 5. Okay, that's not looking good to be rational because it doesn't have any kind of repeating pattern. It doesn't look like it's terminating. And so I do alpha y equals number 4 and see that it spits, oops, I did not do the right thing. Hold on. Square root of 4 plus square root of 5. Okay, I do alpha y equals number 4, and it still spits back out that 4.23606. And then 7977. So since it would not become a fraction, that is considered irrational. All right, number 5, 1/2 plus the square root of 2. Now, I don't want to take the time to type in 1/2 because not that it's that time consuming, but whenever you could type in something simpler like 0.5, feel free to. 0.5 plus the square root of 2 is that, and then if I try to turn it into a fraction by doing alpha y equals number 4, did it turn into a fraction? So that is irrational. 1.914, 2135, 62. And so that would be considered irrational because it did not terminate, it did not repeat, it did not become a fraction. All right, 4 plus the square root of 7. You get that? If you try to turn that into a fraction, it just spits right back out the decimal, which means it's irrational. 6.645, 751, 311, so that's irrational. All right, number 7, 0.0675 plus 8. Do you think that's rational or irrational? It's rational. It terminates after the 4th number, and when you go to turn it into a fraction, it becomes a fraction, 3,227 over 400. So that is definitely rational because it became a fraction. All right, number 8, negative 0.5 minus the square root of 9, negative 0.5 minus, I'm going to save some time here. Instead of typing in the square root of 9, what do you think I'm going to type in? 3. And I get negative 3.5, which terminates after the 5. And then I see that it becomes negative 7 over 2, which is a fraction. So it is definitely rational. All right, what is the square root of 3 minus the square root of 3? 0. Is 0 rational? Yes, because any whole number, even 0, can be put over 1. So that is rational. All right, number 10, the square root of 2 times the square root of 50. Right, because the square root of 2 times the square root of 50 is just the square root of 100, and the square root of 100 is 10. And 10 can be put over 1. Any whole number can. And so that is rational. All right, square root of 64 times square root of 4. Well, isn't that just the same thing as 8 times 2, which is 16? Or 16 over 1, which is a fraction, so rational. Square root of 10 times square root of 8 is square root of 80. So you can either just type in the square root of 80 if you realize right away that it's the square root of 80, or you can type in the square root of 10 times the square root of 8 and you'll still get this number. When you try to turn that into a fraction, what happens? Nothing. It spits back out the decimal, so that's irrational. All right, number 13. You can type it in, or you can just say, oh, well, that'd be a 7, that'd be a 3, so 21. Or 21 over 1, which is a fraction, so rational. Same thing with number 14. Even though there's not a dot to represent multiplication, they're touching, which represents multiplication. Square root of 2 times the square root of 8 is the square root of 16, which we all know is just 4. Or 4 over 1, which is a fraction, so rational. Okay, number 15 is another one that I wouldn't really want to waste time typing it in. What's the square root of 3 times square root of 12? Square root of, remember, they're touching, which means multiply them. What's 3 times 12? 36. And then that's over 5. Well, what is the square root of 36? 6. So wouldn't that just end up being 6 over 5, which is a fraction, so rational? And then pi plus the square root of 4, isn't that the same thing as pi plus 2? And that pi is always, always irrational. So 5.1 or 5.141592. And then 654. And so irrational, pi always is. And then pi plus the square root of 2 is that, and that also will not become a fraction because it has a pi in it. 4.55580. 6216. So that's irrational. Okay? On the page, I did because if you don't, it looks like a number that terminates, which would technically be rational. The main thing I just want y'all to understand is whether it's rational or irrational, because that's what you'll be tested on. Okay, now that we're done going over rational and irrational, flip back to page 22. We're going to continue practicing radicals, but we're going to be doing area and perimeter with them. All right, number 1, the directions for this problem say find the area and perimeter of each square. Well, first let's just look at the area. How do you find the area of a square? Okay, length times width. Some people also call it side squared because with a square, all 4 sides are the same. But it's okay, we'll just use length times width, that works as well. Well, with a square, if the length is the square root of 28, isn't the width also the square root of 28? And you multiply them. What's the square root of 28 times the square root of 28? Remember yesterday I taught you that rule? The square root of 28 times the square root of 28 would be the square root of 28 squared, right? And they cancel each other out because they're inverse operations, so it's just 28. So for number 2, if the length of this square is the square root of 240, so would the width, or so is the width. And then what's the square root of 240 times the square root of 240? 240. So what would the area of number 3 be? 125. What would the area of number 4 be? 175. Now, number 5 is different because now we have a number on the outside other than a 1, so you're actually going to have to do something with it. Remember, if this is still a square though, so if this side is 3 square roots of 8, so is this one. To find area, you just multiply the length times the width. So 3 times 3 would make 9. The square root of 8 times the square root of 8 is 8. And so 9 times 8 is 72. All right, number 6. If the side of this square is 2 square roots of 24, so would this side. So is this side. 2 times 2 is 4. The square root of 24 times the square root of 24 is 24, right? And then what is 4 times 24? 96. All right, number 7. If this side of the square is 3 square roots of 12, this side is as well, then you multiply them, because for area, you just multiply the length times the width. 3 times 3 is 9. What's the square root of 12 times the square root of 12? 12. And 9 times 12 is 108, right? Okay, so what would number 8 be? First, you would do 4 times 4 and get, and then the square root of 27 times the square root of 27 is just 27, right? And then when you multiply those, you get 432. For number 9, you would do 4 times 4, which is 16, and then the square root of 45 times the square root of 45, which is 45, and then 16 times 45 is 720. Okay, now let's go to the next page and do area of a rectangle, because how is the area of a rectangle going to be different? The sides are not the same. Like this side and this side of a rectangle are, but not the length and the width. So look, the length is the square root of 28. The formula for area is length times width, so we're going to multiply that by the square root of 7, and that would equal the square root of, what is 28 times 7? 196, and then you check it to see if it's a perfect square. If it's not, you would have to factor tree it. What is the square root of 196 though? 14 is a perfect square, so you're done. Had it not been a whole number though, you would have had to have factor treated it and given the simplified answer. All right, number 2. This time the length is the square root of 63, and we're going to multiply that by the width, which is the square root of 7. Well, the square root of 63 times the square root of 7 is 21, because it's a perfect square. All right, the next one. The length is the square root of 250. We're going to multiply by the width, which is the square root of 10. And that would be the square root of 2500. Or the square root of 2500 is 50, because it's a perfect square. But remember, if you get a test question that's not a perfect square, at this point you would factor tree it and write your simplified answer for the area. All right, number 4. The length is the square root of 96. The width is the square root of 6. And that would become the square root of 96 times 6, which is 576. And then the square root of 576 is a perfect square, 24. Okay, we got to move on to perimeter now. So go back to the squares and let's look at perimeter. How do you find the perimeter of a square? How do you find perimeter of any figure? Add up all the sides. So if this is a square, this side is the square root of 28, so this one is also square root of 28. And this one, and this one. Well, isn't there an understood 1 in the coefficient place on all of those? So when you add them, isn't that just 4 square roots of 28? Okay, but you can't leave your answer like that. You would have to simplify it. So you would factor tree 28 and get 7 times 4, which would become 7 times 2 times 2. Circle the 2's. Kill one of them, kick one of them out, and then put the 7 back in. But then don't forget about the 4 that would multiply by the 2 to make a 8 square roots of 7 for the perimeter. Does that make sense to y'all? Listen, if I'm not checking this worksheet, So if you feel like you're going to learn it better by just watching me and not worrying about copying, I don't care if you copy down any of this. I just want you to watch and learn. If you need to copy it down to be able to learn, that's fine. Okay, but I would rather you just watch and not copy than spend all your time copying and not learning. Okay, so now let's look at number 2. The square root of 240, if that side is that length, then this is a square. All of them are the square root of 240. Okay, well, for these, all of them have an understood 1 on the outside. So that would be 4 square roots of 240. Well, at that point, you just simplify. So 24 times 10, 6 times 4, 5 times 2, 2 times 3, 2 times 2, 5 times 2. So we have a pair of 2's and then another pair of 2's, but they're really separated, so I'm just going to do it like this. 3 and 5 were the only thing not circled, so they'll go back in. Kill one of each of the 2's, kick the others out, putting 4 on the outside, but don't forget about that 4 that will make it 16. Okay, let's look at number 5 because it has an outside number. This is 3 square roots of 8, so all 4 of them are 3 square roots of 8. Well, wouldn't that just be 3, 6, 9, 12 square roots of 8? But then that's not the final answer because you would have to simplify the 8 and you would end up with 24 square roots of 2. Does that make sense? Okay, now for rectangles. The only difference is all 4 sides are not the same. The length over here is the square root of 28, so this one is as well. This one is the square root of 7, so is this one. So you have 2 square roots of 7 sitting here, and you have 2 square roots of 28. And remember, for perimeter, you add them all together. That's why I put a plus between them, because we're adding up all 4 sides. We have 2 square roots of 7, and we have 2 square roots of 28. Well, this one's simplified, but this one's not. So I'm going to factor tree that 28. So that would be 7 times 4, which would be 7 times 2 times 2. Circle, kill, kick out a 2, put the 7 back in. Don't forget about that 2 that will now turn this into a 4. Then when you add it with this 2 square roots of 7, isn't that now 6 square roots of 7? All right, we got time to do one more. Let's do one with numbers on the outside. Let's look down here at number 7. Okay, if this side of the rectangle is 4 square roots of 63, so is this side. And if this side is 4 square roots of 7, so is this side. So don't you have 8 square roots of 7 when you add them together, and then 8 square roots of 63? Well, this one will simplify. 9 times 7, which is 3 times 3 times 7. Circle, kill, kick out, put back in. Don't forget about the 8 that will now make that 3a 24, right? So we have 8 square roots of 7. We have 8 square roots of 7 now, plus 24 square roots of 7, for a total of how many square roots of 7? What's 8 plus 24? 32. So that would be the final answer. I know that was fast, but does it make sense to y'all how these work? We'll work a few more on the review sheet, which I'm about to give you. You are going to have 6 nights to work on this review sheet. There's 25 problems, so if you just do 4 a night, maybe 5 one night, then you will have